Hi guys, Sam Marsden here from the Wolfhound channel. So this is my first video in a series of videos that I'm going to be doing on Python for engineers and for beginners. And there's a lot of YouTube videos out there on Python, but the reason why I think you should watch this one is because I was a mechanical engineer, knew nothing about computer programming, and I've transitioned over to being a full-time robotics engineer and programmer down in London as part of my job. I've worked with data analysis side of things. I've also worked with controlling sort of things in the real world, which is sort of very different from sort of the sort of pie in the sky, just making numbers move around. And what I'm going to get into with these videos is the skills and the techniques and the sort of information that you need to basically be a computer programmer if you want to be, or if you're an engineer, just the things that are going to help you in your day-to-day life. As a mechanical engineer, as an aeronautical engineer, as a chemical engineer, you work with Excel spreadsheets, you do control over devices at times, or you work with software packages. And in those software packages, everything that drives them in the background is computer programming. And you can interface with them and create tools that will speed up your life and make it a little bit easier. And I'm going to teach you all that, hopefully, in the next video series. And the reason why, to give you a flavor for sort of the things I've worked on self-driving vehicles, which was very interesting. I've worked on communications, so sending data packets from one device to another device. Not just as interesting, if I'm being honest. And I've also worked on, I work on robotics for a start. I've worked on control systems as well, so PID controllers and things like that. And I've also most recently basically written my own text-to-speech dyslexic software because I didn't want to buy it, it was 200 quid. Sat down for a few weekends, and within a month I had my own software up and running. And that is the key, that is the power of Python. So why Python? That's a really good question, and it comes down to my experience where I have come across 4 main programming languages. There are a lot more out there, but there's Python, Java, C++, and Ladder. Ladder is a bit different from the other 3 because it works with PLCs, which is real-time computing. It takes away sort of the asynchronous aspect of things to be more deterministic. So unlike your PC or a Raspberry Pi, there's not as many asynchronous operations going on. You want to eliminate them so that it can be more deterministic and essentially safer. So it's used for things like robotics, assembly lines, think sort of Amazon warehouses, stuff like that. But to bring it back around to C++, it out of the bunch is the most powerful programming language because you can get the highest performance out of the specific hardware you're using. And that's useful. But the problem is that C++ is not the easiest language to pick up and learn. It's also not the easiest language to write code for. And that's important because you're going to be working in a team, and your team members need to understand your code and what you've written, but also you need to understand their code, and that's critical. So what gives C++ its performance? It all comes down to the fact that C++ is a compiled language. It uses something called a compiler, which takes the code that you've written and interprets it into machine code that the CPU or the specific bit of hardware you're working with understands. And that is optimized for that bit of hardware. So it maximizes the performance and the speed that you can get out of it. The issue comes whenever you want to change the hardware you're using, for instance, like going from AMD to Intel chips, and you need a different compiler for that. And this can get expensive, and it can get time consuming, and it can cause you trouble in the programs that you write. So that's something you have to bear in mind whenever you're looking at C++. If you want something more flexible, then you can go to Java. And what Java does is, on startup, it essentially interprets the code and creates a byte file, which is compiled at sort of the startup runtime. But the differences from C++ is that it doesn't run right on the hardware. Instead, You have your OS, you have your Windows, your Linux, your Mac OS, and it creates a virtual machine that sits on top of that. And your code runs inside that virtual machine. And that makes it multi-platform, but it also comes at the expense that it's not optimized for the bit of hardware that you have. So that's Java. Moving on and to discuss Python, and the benefits that I see with Python is probably arguably the slowest of the three, because Python instead is interpreted line by line and then turned into bytecode. And this bytecode, similarly to Java, runs in a virtual machine, the Python virtual machine. And you might say, okay, so if Python is taking this hit as well and it's not quite as fast as the other two, why use it? Because essentially, whenever it comes to doing different types of projects, you need different tools. If you want an engine management system that is time critical and needs to work in milliseconds and be accurate and control a lot of different outputs very, very rapidly, then sure, C++ is your go-to. Same with robotics or self-driving cars. If you're looking at wanting to navigate a road and you have a lot of variables, C++ is going to be your best bet. But whenever it comes to other projects like in engineering, where you're looking at stats and statistics, where you're interpreting data. For instance, I worked on a project where it was sheep, and it was the treatments they had been given, their death rates, their parents, so their sort of heritage and stuff. It was a whole bunch of Excel spreadsheets. The data was all scattered. There was parts where the data was missing. And I was able to bring all those Excel spreadsheets together over, I think it was 2,000 specimens, animals, and then produce one output spreadsheet that had all the data in it, that had it all laid out in the correct way, and had the results and an analysis for each essential sheep that have undergone treatment over a time period. To write that in C++ would have taken me days and would have been time consuming and tricky. I wrote it in Python in a matter of hours. And that's the difference, is if you need something that is time critical on your hardware, C++. If you need something that's a one-shot that doesn't need to be time critical, that is to do with these analysis tools, because you don't care about how long it takes you to get to that final spreadsheet. If it's 100 times slower than the C++ code, fine. It takes a minute to run instead of 10 seconds. But the difference is it saved me days of work. And that's the key with Python. Python can get you to the final answer faster than some other languages because it is easier to work with and it's easier to write. So this is why I think Python is a great tool for engineers. Because yes, it doesn't give you the maximum performance, but it is incredibly easy to write. And I worked in a simulation and modeling department as part of my engineering career. And there we really used Python because we were interfacing with people who were doing CFD analysis, FEA analysis, and CAD design. And my boss would come with ideas and features and functions that we wanted to add or we wanted to bring into our work, or statistics that we wanted to get out, and we would put stuff together. And that came down to us interfacing with those individual packets. So to give you an example, in SolidWorks, if you wanted to find the narrowest aperture of an irregular shape, you can drop a plane, you can take an intersection, and you can measure the circumference of the part that you've sliced. And you can drop that plane the whole way through the object. Now, to do that manually is quite challenging and going to take you a lot of time, unless you're a graduate. But you can write a program that can do that. Similarly in CFD, if you want to run a whole bunch of different test cases, you can set up your simulation with the start parameters and all the rest of it, but you can automate it so that once that finishes, another one runs, another one runs, another one runs, and you can work within the code there itself to automate that process for you. So that's where the real power of Python comes in, because that setup is easy to do. It's not time expensive for the computer because you don't care if it takes a few more minutes just to do the setup, and it saves you an awful lot of time in writing. And also it can be deployed in all the computers that you're using, regardless of the architecture or whatever that they have. So I hope that explains why Python is such a powerful language. That's where I'm going to wrap this video up for today. Like and subscribe and hit the bell to stay notified. And until then, I'll see you next time.